Hi guys, today we're going to see how to build a two-wheel bot. It's called TubbyBot. It's a Wi-Fi or smartphone controllable bot. It's not a self-balancing bot. Instead, it uses a metal ball roller as its third support. Now let's see what components do we need for building a bot. Like you'll need a 3D printed housing, which I built using FreeCAD and printed using 3D hubs. Apart from that, you need a Wemos D1 Mini ESP8266 board and its motor shield, battery shield, Lipo battery, RGB LED, or you can build on one on your own, a buzzer, a magnetic reed switch which I use to power OLED display, Planetary gear motors, they are slow moving motors, a magnet and metal ball roller.
About the enclosure, so this is the bottom part and this is the top part. If you see, this particular cavity is done for the OLED display, and here this placement is for putting the ESP8266 microcontroller, something like this. The top part will also be coming above this, the motor driver, but I'll show you just it goes like this. And if you see, this part shows the USB as well as the charging USB. This is for programming and this is for charging. And I'm not using the battery slot, instead I have soldered from the back side those two wires, so the surface remains the same. I don't have to pull it from the other way, and the motor will go here, and the enclosure will be like this. Let me also show you the 3D printed wheels. So this is the wheels. So the wheels here, I printed all of them using FreeCAD design. I designed and then printed them. Before doing that, I need to measure the dimensions of the motor and place them like this, and the dimensions of the Wemos D1 Mini microcontroller board, and place them like that. And the initial design was something like this. I 3D printed a design like this, and then I later changed my mind and I went for design something like this. So if you see here, you have the slot for the motor and for the wires to go through the slot, and the holder for the Wemos D1 Mini, and the slot for programming and charging. And here in the front, if you see, there's the OLED display slot and the gap for the wheels to be placed. And do it up here, something like this. So like this. So the next part is the electronics. Like here you can see the schematics of the TubbyBot. It consists of 3 shields. I'm using Wemos D1 Mini microcontroller. The microcontroller is here. It has a USB interface for programming, and it's just a Wi-Fi enabled device. The further version ESP32 provides you Bluetooth and Wi-Fi combination, but still this is not available for Wemos D1 Mini at the moment. So this is the battery charger, and this goes below this, and on top comes the motor shield. Now I have already soldered them, and you see more or less I can give you an overview. Like if you see, these are the two motors connected to the motor shield, just similar to that, and the same bus, I2C bus, is used for that is the GPIO 5 and 4, or used for the clock and data line, and for the OLED display. So these two devices, motor shield and the OLED display, use I2C and use the same line. The next one is the RGB LED. I've connected here. I've soldered it on top. Not the best way, but it works. So I used the GPIO 12, 13 and 14, that is 6, 7 and 16 of the pin number, and D8, D76 from the D1 Mini. This goes to resistor, and then the RGB, and then to the ground. So this is the simple schematic of the bot. Yeah, if you connect them in the 3 order, it should work. Really, yeah, but no, it won't work that way, because there were other problems with this motor shield, and that I had to correct them. The reason is because there is a motor shield controller. It's controlled by STM, and that had a firmware which is faulty, so it won't work straight away. So I had to reprogram it using FT232 dongle, USB dongle from SparkFun. I'm sorry, USB programmer, or USB to serial converter from SparkFun, and then solder the pads that enables I2C interface instead of IO interface. I don't know what it is or how it works. I directly went for the I2C. So that's all from the schematic side. I will anyway be putting the schematic in the description below. So this is the magnetic reed switch. So I'm trying to give the connection to the reed switch ground to the Lipo battery ground, and from the other end of the reed switch will go to the ground of the battery supply. And the positive terminal will go to the positive of the battery, say. Now on is growing green, and if I expose it now, you could see that it's turning to red. It means that the circuit is closed and connected, and now it's charging. So on charge it shows red, otherwise green. So now this I'm going to use as a ignition switch. Like I'll have the battery powered via a magnet placed here. This is the idea behind it. So for that I just cut apart the thin sheet of metal iron basically. So this works. So I'm just going to glue this part here somewhere, and the rest will be taken care by the magnet. That this is done, I'm going to put this part to stick with this part here. So I'm going to use this when this part is drying. Let's get started with the motor part. Like if you see the motor, it should actually go like this. When I built it, it was planned with the kind of tolerance, but now it seems to be a bit more, so I need to kind of increase the thickness of the motor. That I am planning to do using a 2 roll of tape. Let's see if it works. So now it's done, and you could see that it has the tolerance what is required. So it will just go and fit and remain tight, which is the expected result. Pretty firm, unless I want to pull it off. So I'm going to do the same for the other motor too. So as you see, both the motors have been taped and the tolerance has been increased, so it will go tight here and it will stay there. This is what they are expecting. So now let's try to assemble the body. This comes the order. If you see like this goes like this. Make sure that you plug the shields on top in the right way. Like you can refer the reset belongs to the reset here, and the 3 volt belongs to 3 volt. If you insert it wrong, you won't be able to identify it otherwise, and it can create confusion, like once it happened that I could not program, and I was wondering why it's happening, and I found that I just simply plugged it the other way. So these kind of problems can be avoided if you ensure that the very beginning. And here goes. Now if you see here, when I printed the board, the design, the 3D print, I did not calculate the size what is required for the charging, so I would need to cut off this part to make it use the battery shield. Let me do that first. So seems to be working, so it's charging, so I would leave it so. Yeah, I would leave it so. Now I'm going to put the 3D printed wheels. It's just a simple interface. I just have to plug it in. So here we have it. So these 2 wires needs to go front. Oops. So this wiring needs to be done. So now it's soldered back. Now let me see the way it goes. Like if you see the yellow color wire, it's actually the power supply for the motors. Like the power supply for the controller is done via the 3 volt on the ground, and apart from that you need separate power for the motor, which I'm actually going to use the same power, so I just pulled the 2 wires and then connected them to the freely available slot where I can just take some power. Yeah. Now by pulling these 2 in the front, and this word, we are done. And now this, it needs to be inserted a bit tricky. First go like that, and then slowly push, since the wheel is the height. So display has to be attached to the front display. I'm going to use the glue here, kind of a bit. I'll leave it for some time here. Connected all of the terminals, that the battery switch goes to the magnetic read switch and then gets connected to the power supply. And I put, say, here and try to kind of organize the cables. It's kind of done. So let me plug the power by putting so if you try to see this, kind of blinks. So the bot is almost done. So what is left is just to stick this caster ball. Got this from Banggood, and this is looking like this. Now I have marked the place where I'm going to stick it. So I'm going to apply the centered. I'm going to leave it for some time and then it should stay there. So when I tried to test this bot, this wheels did not have enough friction, so I had to kind of coat it with a rubber like material, and I found this ABS latex, a white color one. So I used this, I applied this along the edges of the wheel, and then it started moving. So here is the Blink app. I have configured the app to get connected with the bot. For more information, visit Blink website. Check the link in the description below. Like if you see, I can configure, add widgets, whatever I want, and then start. Here I have configured a joystick, an RGB LED configurator, and a button for horn. Now if I play, if it shows nothing as an error or anything, it means that it's already connected. Since the TubbyBot is already powered on, you can directly play like this and see the action in the background. So now if I move, so now if I make the RGB LED, it glows there. And this is the horn.
for watching the video, and please subscribe, share and comment if you have any feedback. Keep following, I'll be making many such videos. Thank you, bye bye.